Larry Simic, I'm from Pinnacle Engineering. My background, I've got a degree in chemical engineering from the University of Minnesota. Back when the chemical engineering program there was #1 over Badger. That's now reversed, so you get that one. But it was still when I was there. Work history, started at Sperry Newek, recovering gold out of computers. I love my chemistry. Was a big user of cyanide back in the day. Eventually moved off into consulting. Got a professional engineering license in the environmental engineering field. Moved into consulting in the environmental engineering field. I was here for since '87. So a number of years. So I've been doing something with chemistry for 30 plus years. The work that I do, you'll see some of the work that Pinnacle does, but just about anything that has to do with chemistry. So chemical distribution, industrial hygiene sampling, air sampling, ventilation design for, not for a place like this, but ventilation design for chemistry again. That involves a lot of toxicology work because you have to look at the toxic effects of a lot of the chemistry you're dealing with in order to design that ventilation system correctly. So you're not using too much air, but you're also making sure that the ventilation system protects the workers that are in that area. So a lot of different things here. Some of the other things we've worked in, transportation and railways. You may remember the derailment just down in Galena. We were one of the companies that responded to that, did the cleanup down there. We're actually up in North Dakota right now cleaning that one up. There's the interesting geology, which we won't get into. Renewable energy, so ethanol, biodiesel work, aggregate. We've done some work in those fields. We don't work in sand mines, I will say that. The only mining that we do is hard rock mining, and that's one of the mines that I work with up in St. Cloud, Minnesota. One of the areas of contamination, somebody decided to break into the mine after hours. They burned every single truck in the facility. They overrid all of the controls in the diesel tanks and pumped diesel all over the place. That's not one that you're normally going to see, but in some of these meetings, some people don't like the sand mining, so we won't get into all that. Talk a little bit. I don't need to talk about that stuff here. All right, crystalline silica. Crystalline silica does have some issues. There was a tunnel that was dug through a mountain out in eastern United States back around, I think it was the turn of last century. There what they were doing is they were fracturing a very specific type of silica. It was creating crystalline silica, which is a relatively hazardous type of silica. Normally we talk about silicosis and other types of silicon-related diseases. You're talking on orders of 30 years. They had such high exposures in these tunnels with no controls or anything. They literally had people dying within two months. That was a very, very extreme version, and you're not going to be seeing anything like that in the world nowadays, at least not in the United States. OSHA. OSHA has a permissible exposure limit of 10 micrograms per cubic meter. This is what the average person that's able to work in a manufacturing facility can be exposed to for 8 hours a day, 5 days a week, and that's legally exposed to. Now, we've got a couple other groups here, ACGH and NIOSH. They've got some different numbers. The reason they've got some different numbers, those are based on newer information. Every time OSHA tries to make a change in the OSHA requirements, they get their butts sued. A lot of people just don't like OSHA changing things, and Congress has got their agenda, and so every time OSHA tries to change things, they get a lot of resistance. NIOSH is the National Institute for Occupational Safety and Health. That's part of the government. ACGH is outside of the government, even though it has a name called American Conference for Governmental Industrial Hygienists. That's just a relic of where the name came from. They base their information on their exposure limits, the recommended exposure limit, and the threshold limit value. Again, 8-hour time-weighted averages on more recent information. So you see that they're much more stringent than OSHA is. Why am I going here? Because everybody wants to know what's safe, right? That's really the thing what everybody's trying to get to. What is safe? Depends on where you're at. Minnesota says for the ambient, so now we're not talking in the workplace. We're talking what's out in just the air that we're breathing every day. Minnesota's been doing some work. California's been doing similar work. They're coming up with 3 micrograms. So if we go backwards a second. All right. So OSHA says 10,000 micrograms, 10 milligrams, 10,000 micrograms. These guys are saying 50 micrograms. And Minnesota's saying in the ambient atmosphere, 3 micrograms. I have not had a chance to find the information on those, how to dig into that. But everybody that I'm reading about says 3 micrograms per cubic meter is where they're coming up with some numbers, and here's how they did that. And the reason why I'm going to get into some, sorry Al. Al talked about rocks. I'm going to talk about chemistry for you with that. The reason I want to talk to you about this is, how do you get those numbers? Everybody throws numbers out and nobody really understands where they came from. So, where we started with, California came up with some numbers that was developed from some mines in South America, South Africa. Now normally when you hear about people doing toxicology work, they've got rats in a lab. In this case, this was an actual mine, and these weren't exactly people rats in a lab. These were actually people out on the job site. And after 30-some years in these job sites, people were keeling over from silica-related diseases. So what they had was, we'll call it a lab out in the real world. So what they did is they went in and said, what is your job function? What do you do? How much are you exposed to? And they started looking at how long people had worked, how much they were exposed to, what different job functions they may have had throughout the years, and they came up with some numbers. They came up with 2 very important numbers. Lowest observed I'm blanking. Lowest observed adverse exposure limit. So what this was is, this is the lowest limit that the workers were exposed to, where they documented that they had an asbestos, or I'm sorry, not asbestos, a silica-related illness. The NOEL, that's no observed adverse effect level. And so what they said is that people that were exposed to this, they didn't see any issues. So somewhere in here we have a kind of a gray area. Then what they did is they took that and put some statistics together, and that's where they came up with this benchmark exposure level, or contamination level. So that's their magic number. Then they said, okay, we looked at the rock that these workers were exposed to. Not all of it's silica, so they diced it up and figured out how much of it was silica. They said, oh, okay, this is really what you can be exposed to from a silica perspective. And that's what they came up with, is for an occupational exposure. 8 hours a day, 5 days a week, 270 shifts per year, over 24 years. Okay, anybody that's in their house, they're not exposed to that, right? They don't stay in their house for 8 hours, but we want to be really conservative. What if, because we want to make sure that we're protecting the most vulnerable part of the population. So somebody that might be in their house all the time because of an illness, respiratory issue. So we want to make sure that somebody that's in their house 24 hours a day, 365 days a year, 10 cubic meters, that's how much they breathe in and out. So this is what the average person at home would breathe. I'm sorry, this is what the average worker would breathe. This is what the average person that isn't working as hard would breathe in a day over 24 years. This is pretty conservative. When you look at all the things that went into this number, very few people are going to have these situations where they're going to be exposed to silica for that long. And remember, we're getting a number that is, they come up with this number as that's the one that they say statistically below that you should be safe. Right? So after all of this math, they came up with what comes out to be 9.8 micrograms per cubic meter. And then there's an adjustment factor. If you want to call it a safety factor, that's really what it is. It's a fudge factor. We don't want to get this wrong, so we're going to add a safety factor. In this particular case, this is a very low safety factor. The reason being, if I'm working on lab mice and things like that, mice their systems don't work the same as humans. So if you're basing your decisions on mice, you might be missing something. So in the case where you might have an animal study, you may have a 20 times safety factor. Whereas in this case, because this was based on human studies, we know the data was actually pretty good. So we take the safety factor divided by this, and that's where the 3 micrograms per cubic meter comes from. So that's the number that, you start looking around on the internet, that's the number that keeps popping up. And I wanted you to see how that number got derived. And part of why we're doing this is because John had asked us, there's a lot of information that seems to be coming out on silica. Minnesota's got issues related to silica mining. In fact, there's a number of moratoriums that are out there. Wisconsin's have the same issue. Some areas down in, I think it was Oklahoma? Indiana maybe, that area, has a fair amount of silica mining as well. And so there's a lot of studies that are coming out now on what's real and what isn't real. I've also looked at some studies on hard rock mining. Hard rock mining is different. In that usually when you're taking that rock out, you're crushing it. And that's one thing I forgot to mention too. There's a big difference between crushing operations and this type of silica mining. Crushing operations are similar to that tunnel that was being dug through the mountain, in that you're just breaking this stuff up. You're cleaving really hard edges. And silica, the worst part about silica is when you sandblast and you could literally hit with something and it explodes. And all of a sudden you've got all these fresh fractures. Whereas this sand, think about where the sand came from. Tell us where the sand came from, Al.
The beach.
It's been in the water. It's been rolling around. It's been getting banged up. Silica is some of the hardest stuff on Earth. So it bangs against each other, and eventually it forms nice little round sand particles. This is not the sand that you usually see when we're looking at some of those industrial hygiene studies where, what's the risk associated with sandblasting? That's really bad stuff. You're busting that stuff up like crazy. Mining, where you're crushing the rock later on, by comparison, sand mining that goes on here is fairly gentle, I guess, because they really want the sand to be round. And when they used it for fracking and they force it in, crack up the rock, they're wedging that little round thing. They want that thing to roll around and get it wedged up into the rocks. All right, so some of the new information that's coming out. So what I did is I pulled some information from a variety of sources. So right now the MPCA is doing some ambient air monitoring. They're going to be doing that for 3 years, and that's at a variety of sites. We've got Winona, that's a community ambient air monitoring, so they've got a couple of monitors. We'll talk about that in a little more detail in a bit. We've got Shakopee, that's an actual mine. Tiller in North Branch, about half a mile from where I grew up. That's a processing center, so they're bringing mine in from somewhere else. There's some work that's been done by Dr. Chris McPierce, and then there's some work that was done, I think this is the EOS, is that right?
EOG.
EOG, sorry, go for it.
What is in Shakopee? What are they processing or mining there?
That's right by the river.
What is it?
Oh, they're actually mining sand
Oh,
and processing it at that location.
okay.
Okay.
For fracking?
Yes, yes. All right. So Winona had some concern about the ambient silica content in the air because of all the trucks going through. They've got rail operations that are bringing sand in and out. And so they said, ask the MPCA, they will show us that this is safe. Remember, this is part of a 3-year study. This is a very early part of it, so this came out, I think, January of this year. So we're not too far into it yet, but some of the data is starting to come out. So when the MPCA, I'm sorry, the Minnesota Pollution Control Agency. So that's our version of the DNR. So the sampling stations, these are EPA method sampling stations that were set up. They were monitored for PM 2.5 and PM4, crystal and silica. They set up 2 of them. One is in Winona and one was in Stanton, Minnesota. What they wanted to do, here's the hard part about sampling. Collecting data is easy. Interpreting the data after you get it is a lot harder. So my first rule of sampling is have a plan for how do you interpret that data because you're going to get some weird results. And so what they did is they say, Winona's got all this sand trucks and everything. But what does that data mean? There's going to be silica there. There's silica everywhere. So they went to Minnesota, Stanton, Minnesota, and which is fairly similar, and they said, we're going to put the same monitoring data there. And we want to look at the comparison. They were calling this the baseline, and then this was what happens when you've got a lot of silica trucks running through. So far the data is showing 30 data points, 28 were below the detection limit, and I apologize, normally I like to go into the reports themselves, but the NPCA was only kicking out some summaries. And so I don't know what this detection limit was, otherwise I'd tell you. The detection limit just means that I can't see it below there. It may be there, but it's pretty low. And then there were 2 detected levels at 0.4 micrograms per cubic meter. Remember the other number that we talked about, 3 micrograms per cubic meter, was kind of where the PCA was saying we're good, bad. And this is as silica, okay? The Stanton one, so they had 33 data points, 9 detected were above the detection limit, and these were between 0.4 and 0.8. So the baseline, without all the sand running through the town, was higher than Winona. The thing they didn't account for is that Stanton has a dirt road running through it and a lot of farming operations, whereas Winona, further down in the valley, farming operations aren't as close and everything is paved. So if I would have set this experiment up, I would have said, yeah, that's what I would expect. So this one wasn't set up as well as it probably should have. But what it is saying is that trucks and they do have some rail traffic with sand is not creating a major issue for Winona at this point. North Branch. So again, this one, I don't know, about half a mile from where I grew up. This wasn't here when I grew up, but there was a couple of nice sand mines that we love to shoot 22s in. Anyway, this is bringing in sand from the outside and then just transferring it onto a rail spur at that location. I think they're doing some fine separation. So they've got 1 sample at the north boundary, 1 at the south. Typically they're seeing north to south or northeast to southeast winds. Right now they've got 11 data points on the north station, so this should be upwind at 1.5 micrograms per cubic meter, and then 11 data points with 1 detection at 1.5. I'm sorry, these are all below their detection limit of 1.5. And then these were 11 data points and 1 was detected at 1.5. So again, with the processing end of it, the data showing it was relatively low. Yes?
Going back 1 slide to the Winona, Minnesota, what were it said there was 2 detected levels?
Yes, in Winona.
Okay, do you know where either one of them were in the geography of the town?
Yes, it is on top of the YMCA. Why they picked that, I don't know.
So, do they have for certain that detections were because of the frac sand coming in and out of town, or is it from something else?
I would say that's just the ambient, what's in the atmosphere. For one thing, I did see the map that showed where the YMCA is basically in the center of town. The rail operations are, you know, up against the bluff, as well as the trucks that are coming through. You know, they aren't close enough that a sampling is going to say, yeah, that's definitely, it's not close enough to tell me that it's from the silica sand operations, the trucking.
I guess why I was asking is because I've been to Winona on a regular basis, and I know they tore down a bunch of houses. And I used to work for a company that did that I didn't know if that contributed to this recorded level.
Because that was up on a higher location, little things around are not going to have as big of an impact.
Well, these buildings were from here to the end of this room from the YMCA.
Okay. Well, I don't know when, I mean, if they took them down, I guess it should have been January 13th. Or,
Those houses were still up there.
Oh, yeah.
Okay. Yes,
Okay.
so that wouldn't have been, I was just curious.
Chances are, because you've got 28 points that are just below the detection limit, and there's 2 at .4, I'm guessing that 28 of these points are just below. And that's just really, your detection limit is pretty close to this. So that's what's going on in the atmosphere around.
Okay. What's the 0.4 in comparison to the safe levels?
Well, the number we talked about before was 3 micrograms per cubic meter, so roughly 10 times below.
Stanton, Minnesota, is that over by Northfield?
Did it one? I can't remember where that one is. I thought it was fairly close to Winona though. I thought it was up on the,
Well, it's sort
I've
of
been on the bluff.
the other side of Cannon Falls.
Is that where it is? Okay. I'm not sure why they picked that one.
Well, it's further away, I suppose, the truck traffic and all that sort of thing.
Yeah.
All right, so we talked a little bit about this. So again, you know, they're not seeing from just the transporting and processing, they're not seeing a lot of impacts related to the processing. Shakopee sand, ambient mine. Okay, so this is a fairly decent sized mine that's operational right now. Again, sampling stations were placed on the northeast and south fence line. They're going to be doing this same 3-year process. So what they did is look at site construction and then the sand mining, blasting, processing, transportation. And they also have gravel roads all around the place. So out of the 44 data points that they collected, and this is PM10 data, this is not silica. I think the MPCA was running out of sampling equipment, so that's what they got. So 42 points were below the detection limit. That's on the northeast station, so that's going to be upwind. The highest detection was prior to the start of construction, so that would have been this 1.8. So that might have been a windy day, a lot of other things could be going on. The south station, no respirable silica data was available. Like I said, it was all PM10 data. And they were seeing between 5 and 55 micrograms per cubic meter. So it looks like, I'm sorry. And this 55, that was one day where they had some blasting going on. Most of the data was down around the 5 micrograms per cubic meter. Chris McPherson is a professor over at UW Eau Claire. He's been making a lot of speeches, giving a lot of information on what he's presenting. I haven't seen any actual papers from him yet. He's using a dust track aerosol monitor PM 2.5 and PM 10 cyclones. The dust track air cell monitor, I've used these in the past. This is what I would call screening equipment. This is equipment that really isn't meant, it doesn't follow the EPA protocols. This is equipment that I would say, I'll put it upwind and downwind and say, you know, this is higher, this is lower, this is lower, this is higher. It's a relative measurement, it's not a definitive measurement. So the MPCA methodologies are definitive. So, you know, some of the data that he's getting is kind of interesting, and he didn't do any crystalline silica sampling, but, you know, you have to take it with a grain of salt. I know that looking at his website, he did say he just bought some brand new equipment that does meet the EPA methodologies, so now he's going to be going back out and doing some additional work. I think he's heard some of the criticism, and I think he had to agree that, yeah, you're right, I need to, if I'm going to be comparing this to EPA standards, then I need to at least have the equipment that EPA is used to. So here's some of the stuff he's come up with. EOG during construction, he had 17 to 22, 15 to 22 downwind. In my world with that equipment, that's almost the same number. Again, upwind 11 to 35, 14 to 32, those are the same numbers. 6 to 23 with no operations, you know, that's still kind of in the same range as a lot of these. They're rather quiet days. So maybe what you're seeing is during operation, the lower end is actually moved up a little bit to say around the 17 to 15, okay? But for some reason, the upper end, well, I guess the upper end was affected a little bit. So yeah, it is moving the numbers higher up here. And then this is some more operational data with just downwind and monitoring. So these were fairly consistent with those. One day that they had a really high number. I think, I'm not sure if there was some blasting on that particular day. Unfortunately, with some of these things that are coming out, they don't have all of the data that's available that I really would like to tear into. Well, there's a few other very similar results on a lot of this. Then we've got a ambient PM4 crystalline silica sampling that was done at one of the EOG. I got my hands on the actual report, and I'm pretty critical of people in our industry. And so when I say that this was actually really well done, I mean they did a very good job. Not only did they modify the samplers to do the PM4, this is not, you know, normally you're just going to buy one unit, snap it on, that's going to be PM 2.5, and then PM 10, snap it on. They had to make some modifications, and they went to the level of, they took dust, they ran it through there, they knew how many particles and different size of the dust there was, and they ran it through, and then they counted all the size of the particles that got through, the parts that didn't, and they were able to come up with a statistical analysis that said, yeah, this is a PM4 sample, this is working. So this was really well done work. The quality control is actually pretty phenomenal. So the data that they came up with, so here's the number of data points at a variety of different mines. So this was their detection limit of 0.3 micrograms per cubic meter. Most of the points were below that. Their long-term average concentration, I'm sorry, this was a percentage. And so their long-term concentration, that was 0.1, that's up top, there's the highest there. And some of this seems like it's agreeing with some of the work that the MPCA was doing, although this was a PM4, so it's not completely comparable. The highest number we saw for a 1 hour or 24 hour was this 8.1. So there may have been an aberration. Again, I didn't get all of the data on this, so I couldn't tear into what happened on that particular day. But it's really telling me that there isn't a lot of ambient silica out in the environment around these mines. So conclusions. You know, the PM, PM10, PM2.5, NOx, SOx, those are already regulated by the state and federal agencies. Wisconsin currently has no existing ambient exposure guideline for silica. So if you're going to look at something, you're going to have to borrow something from another state. It's not going to have the force of regulation behind it. It's going to have some type of operating agreement with the state. The ambient exposure guideline of 3 micrograms per cubic meter is referenced by a number of regulatory agencies, and it's actually got built on human exposure data, and it provides good consideration for the most vulnerable part of the population. The ambient air monitoring that's conducted at a number of sites are already indicating that there are low levels of crystalline silica around these areas. So that's that. Questions?
Yes, when Al was up there, I asked him to analyze the story of dumping, fuel and milk and the polyacrylamide over the bridge.
Yep.
We've got crystalline silica coming from an origin of non-metallic industrial sand mining here. What other, the study here from the county, it references a lot of different particulates in the air. Some come from diesel, some come from different origins. What other types of things in the air?
I had a facility that we were working with. These are not exactly Boy Scouts. They read all of the hell they got from the MPCA. But they were forced to have 3 monitors around their facility and monitored, same thing, 3, I think it was for total PM. And every year around planting, they would get a notice of vibration. Well, what do you expect? And then they would get another one at harvest. But farming is a big contributor to particular emissions during those short periods of time. Dirt roads, you've got silica on all those roads, you're fracturing that silica, that's another big contributor. Diesel particulate, they talked about that in there. Diesel particulate is going to be a hard one to regulate as part of this operation, because where do you start and stop? EPA is already has an initiative. You have to have filters on diesel trucks now. Any diesel engine for a railroad operation, once it is built, it has to be brought up to a new standard. New diesel engines have to meet certain NOx emissions. NOx also contribute to that PM 2.5. Diesel trucks are running on extremely low sulfur, ultra low sulfur, which contribute to the PM 2.5. So there's a lot of things that have been done with diesel trucks, but to pick out, the sand mining operation versus chicken operation that's sending out product or furniture. I mean, you've got a lot of trucks that run through this town. You can't say the diesel particulate here is good and the diesel particulate there is bad. So I mean, that was one problem I had with that report. Other sources would be industrial operations. So manufacturing plants that, especially that have combustion units, and also power generation. The PM 2.5 that is really has the greatest concern is stuff that, it's so fine that it's not normally made by fracturing things. It's by combustion units that burn something and then it emits it as a vapor phase, so it kind of is a gas. But this is something that as it cools, it's not going to stay a gas and it's going to condense. So it's a really, really fine particulate. And that's where this PM 2.5. So when you're looking at the PM 2.5, the biggest sources are combustion units. Other operations. Well, PM 2.5 is one thing that report doesn't talk about is if you look at Wisconsin's ambient monitors that they have throughout the state, look at the PM10 and PM2.5. I believe, I don't have the notes in front of me, but I believe between, I think it's 2000 and 2013, there was something like a 31% reduction in PM10. So these numbers are going down. All the things that the EPA is mandating are making an impact. Some power plants are giving up their coal, well, in Minnesota's number, they're giving up their coal burning and down to natural gas heat shaving plants. And those have significantly less emissions than 2.5.
At the beginning of your presentation, you talked about crushing sand for different operations. What type of application would that crushed sand
Well,
be used in?
No, I'm sorry.
Maybe I misunderstood.
Yeah, it was hard rock operations.
Oh,
So when they're crushing, like up in the one we work for up in St. Cloud, that's a granite operation. They crush it for rail ballast and some other decorative things and that kind of stuff.
I misunderstood.
Any other questions? Yes?
Have they done monitoring around like that granite plant up by St. Cloud or by any aggregate or gravel mines when they're crushing?
Yeah, actually the company that did the work at EOG, what was their name again, sorry? Oops, went too far. Oh, no, didn't have the name on it. Oh, I'm sorry, Air Control Techniques. In California, there was some requirements that you had to do for the crushing operations. They are requiring ambient monitoring. And so these guys have done some monitoring at some of the facilities down in California. I saw one of their reports, and that was showing similar results where very low ambient levels. Yes?
What is the cost of one air monitor? The PM2.5.
Minnesota has a great little fact sheet on their website, the MPCA's website, and I wish I could pull it out of my head, but if you search around, start looking for silica mine on the MPCA's website. They have something that shows the costs for all of these things, the cost to build the pads, to place them, the cost for the equipment, the cost for the operation. They've got all of that.
When you go back, can you link that to me and email it over?
I can do
And
that.
I'll make it available.
Sure.
We've had a couple of, are there any other questions from the common council members for Larry on the air stuff that he's talking about here? If not, because of the late hour, I think we'd invite Larry and Al to kind of wrap their stuff up. And, I had asked you at the last meeting, and the council was interested in getting you this information. Provided an analysis and a summary for what you've been able to review this far of the report for the one-year moratorium through the Trumbull County process that they went through. And then at the beginning of the meeting, I had mentioned that we were going to be having another meeting. And then, in late May, early June, at that point, I asked you guys to finish that summary and analysis of the rest of the report if you haven't gotten it done. But by all means, Al and Larry, if you want to go first and then you wrap it up, Al, or however, because I imagine a lot of these folks are getting up as early as I am tomorrow morning. So if you want to give any kind of an analysis on it.
Just real general points. One of the things that I like to do when I issue a research paper or white paper is actually go, if I'm going to reference reports, go back to the reports. The one big criticism I have with how Trumbull County did it, they used reports of reports. So they didn't go into the actual published paper and tear apart the data and really look at it hard. That's probably one of the biggest criticisms I have. One of the, I can't really say is criticism, But it's a lot of the information I'm presenting here today. This is all new since that report came out. So I mean, the body of data is coming out fairly quickly right now. And so it's kind of adding to what we know and what we, hopefully dispelling some of what we don't know. There were some things that in some of these references where they looked like they cherry picked a little bit. Like the reference, they had referenced air trends. Air trends actually talked about the decrease in PM10 and PM2.5 that Wisconsin is seeing in all the monitoring that they're doing right now. So that was one of the criticisms I had. Talk about these are such big issues, but at the same time, across the state, these levels are going down. Okay, that might be I talked a little bit about the diesel particulates. There's a lot of things that are going on. That was brought out as a fairly large issue. But there is a lot being done with diesel particulates right now. They brought up NOx from blasting. To me, that's a complete non-issue. The only way you would have a problem with nitrogen oxides is if you had a confined area close to the blast where any emissions couldn't have dissipated. NOx break down fairly quickly, and with the amount of dynamite you'd be using in the mine, I can't see anything other than a very confined space inside the mine there would be an issue. And then the crystalline silica issue, that's a lot of information is coming out right now, so I think that's becoming, in my mind, less of an issue.
And then they had recommendations from their quality subcommittee. I think they had 7 of them here. Are those pretty reasonable, or how did you view those? Because when we make a decision as a town council, that's got to be based on, fact and data and being able to be substantiated. And we want to make sure that, we use all the data that we collect to make the right decision.
Sure. To me, ambient sampling around town just to see what the combined effects are, I don't think that's going to be very useful, because you're going to have spikes, you're going to have things that happen completely unrelated. You have a windy day. So trying to explain that, is it this person, is it this person, or is it something completely unrelated? My first rule, like I said, of sampling is you have to be able to interpret the data and have confidence that you can interpret the data. Collecting data for the sake of collecting data is not a good idea. And I don't think you'll be able to interpret that data very easily. Putting sampling locations close to the mine and saying, we want you to stay below this level, or stay below, upward and downward increase, to me, that's a better way of doing it. If this was part of an air permitting process, what the DNR would do is they would look at individual operations and then conduct some modeling. And the models are very, very conservative. They look at, okay, if this is my ambient concentration, normally what I've got in the atmosphere, and I've got this operation, here's the impacts that happen further and further away. And I can actually model all of these other locations and get an idea of, am I going to see, kind of like you were talking about with your little rings that come together. Do you have multiple sand mining operations that come together and they create a hot spot? That's what that modeling can do for you. If you're looking at what's going on in the entire area, that would be how I would do it, rather than just putting up meters.
Analyze the...
Based on the data that's starting to come out, having somebody monitor for the rest of the life of the mine, is it necessary? I think you set up the monitoring and look at the data and then make a decision later on. But at least if you don't need to spend the money doing that because the data is showing that it's not an issue, then don't monitors. Have a sunset of some sort.
Okay. And then after you're done with those summaries, or those recommendations from the air quality subcommittee, I'm assuming you're done with it if you're not continuing on. But then, just touch on the risk of this in our community, and if there's other risks that we should be concerned about, or where any of these particles or particulate matter in the air, where's their source, what's it coming from that we should be concerned about?
Minnesota. That's where it's all coming from. But yeah,
Take it home with you. Well, I told my council this story a couple of times of, we had a little lady that we doctored for on and off over a 3-year period up in Rochester, and, I want to be able to go home and say, this is the risk, we're not going to take it, or this is what we need to be concerned about, and everybody who's here, I want them to be able to, have that same peace of mind with their family.
And that's exactly why I wanted to show people how the 3 micrograms per cubic meter, how that was developed, because there's a lot of safety factors that go into that. And so, if you're confident that that's a decent number, then, that's what we should look at setting as our baseline. And remember, that was a 24-year number. So, some people get really excited if I go over that 3 micrograms per day. But if my average is well below it, and I have a couple of excursions, you don't want to have lots of excursions. That's not good. But a certain amount of allowable excursions, so say up to 10 micrograms, we have to go to the number.
After your last report, I took that same idea home, and we were talking about it, and correct me if I'm wrong, but I likened it to hitting your thumb with a hammer when you're building a doghouse. It hurts like hell when it happens and you curse out the hammer for doing it, but your thumb's going to be okay. But constantly beating the hell out of your thumb, that's where the damage is going to come.
Yeah, exactly. One time doesn't, it hurts like hell.
I would think somebody else do that.
So we'll deduct it from the bill here. Do you have anything else to add? Otherwise, I look forward to seeing you at the next forum where the public's got the opportunity to ask questions, and then we can do an analysis of any projects that come in.
That's right, for sure.
That's okay. Al, you want to do yours, and then I think we can wrap it up with the statements from the DOT, and then I think we'll wish everybody good night.
Again, my critiques and criticisms.
Where'd you buy those horns? Where did you buy the horns?
See, I told you.
That's right. I know how to play that.
But the critiques or criticism in the report, along the same lines as Larry, is that they're recommending monitoring, doing a lot of monitoring, and without a predetermined use for that monitored information. It's kind of useless data. I mean, it's going to just take up space. The usefulness is not pre-programmed into why we're doing this. And until they decide, like what agency, what county agency is going to utilize this, in what manner, the study, and just making recommendations to gather data is kind of a pointless effort. And they did that in a couple of different sections. The groundwater recommendation, one of the recommendations was to monitor all drinking or all wells within a mile radius of a mine, and which makes sense if you've got a house directly down gradient from the mine. But at a mile range, as I mentioned in my talk, that in a mile, it could be 35 years before the water that's flowing under the mine gets to your well. So, 35 years down the road before anything shows up, it kind of negates the usefulness of data gathering, other than background information. A round of background sampling will give you some usefulness, especially for ambient, like ambient air, ambient water quality, you'll determine that, we've got high iron and manganese in the area. That kind of stuff. The DNR is actually still surprised, when we turn in background levels of iron and manganese that exceed the enforcement standard. Right now, and it's not attributable to anything other than this is what background water quality is like in the area. So again, the usefulness of the data gathering needs to have some plan or some order to it, to doing it. I thought the most useful recommendations pertain to reclamation plans for the mine. All mines have to prepare a reclamation plan, and the reclamation plan is based on what the desired outcome of that property is. So if it's expected to go back into agricultural use after the mine, what is the performance standards for that agricultural land? And how long is it going to take to achieve it? It's helping to develop a plan of action to get from a mine to a cornfield, or to get from a mine to a housing development. What's it going to take? What are the performance standards required to be looking at to get it to that point? So some of those recommendations were good regarding reclamation, and we're pursuing those regards. Conditional use permits need to be made sure to incorporate into reclamation plans. I just reviewed a reclamation plan for a township in Jackson County, and they sent me a copy of their conditional use permit. I don't know if they intended to do that or not, but I took a look at their conditional use permit and compared it to the reclamation plan, and they had talked about creating a lake and hiking trails and roads on this property. And the reclamation plan addressed the lake, but they forgot to include things like trails and roads, which all should be incorporated into the reclamation plan. So the reclamation plan is as good as the planning that goes into it. So reclamation plan recommendations are good, and they need to be followed through. Review of those reclamation plans need to be incorporated with conditional use permits, or operational desire, operational agreements. All those things need to be included when writing, preparing a reclamation plan, or they need to be rewritten if they're forgotten.
So the Trimble County report doesn't have all a good scientific base unbiased report?
And the reclamation plan?
No, the full report.
Oh.
140 whatever pages.
It has a definite bias. It presents, they bring out in the start of the report, they talk about key findings. And their second key finding is that mining brings in good quality jobs. But they use what's called a negation in turning that around. So here you have a positive key finding, but they include the word "but" in it. And they say something like, here, actually I can read it to you. They say, the second key finding states, mining creates quality jobs that can increase income. But they don't leave it at that as a key finding. They put but it decreases community stability because of its instability and impact on quality of life. So they turn a positive impact, our key finding, into a negative by what's called negation, by including that, but this happens. So, and they do that throughout the report. So in the end, there are no positive mining key findings. They're just all negatives. And they do that throughout the report. The air quality section, Larry mentioned a little bit about that. They have studies at the time this was written that they reference in the report that was done in Chippewa County, but they negate it by saying a study by Richards and Gozels, and then they use the language, has failed to show an increase in ambient silica attributable to the industrial sand mine. Now, that means that the Richards and Gozels report is a failure? I mean, that's the implication of the language that they use by stating has failed to show an increase in ambient air.
What would be another way of wording it?
Well, the more proper way would be to say that the study showed no increase in ambient air silica. So instead of saying they failed to do something, they failed to show an increase, the proper way would be said the study did not indicate an increase in silica, ambient air silica.
The media does that all the time.
Yeah,
They fail to convict so-and-so when they can't just say, well, maybe he was innocent.
Yeah, that's right, but that's the implication, So the implication here is that they failed to do it. And then they go on and discount the study by saying the Chippewa County sampling is discounted through showing no additional ambient air silica, by stating that the study has not been independently reviewed and questioning sampling sites and wind directions. So, you can shoot from the hip and say, well, they did that study, but they did it wrong. That kind of thing. On the basis of groundwater, the groundwater is really, the main concern is they're asking for basically too much data to be acquired with no useful purpose for that data. If they want to monitor the water quality, let's say in the upper Eau Claire formation, which a lot of people have their drinking water, then they specifically need to address that. We need to look at water quality in the Eau Claire aquifer, and which would mean that they need to sample a lot of private wells to get a background of water quality from wells completed in that aquifer, and compare it. Well, in the case of most mines are not going to complete from the Eau Claire because they're not going to be able to get enough water for operations out of the Eau Claire. My recommendations based on review of that was that the city is concerned about the Mount Simon, because the Mount Simon formation or aquifer is what the city is getting their water on. My recommendation is that any mines soliciting permission within the city limits need to model the Mount Simon, much like the Arcadia Sand Mine did, using data provided by the city, and then that information needs to include modeling of the upper aquifers also. That information needs to be submitted to the city as well as the township for general information dispersion. That and the requirement for making sure that wells are constructed according to code and made single aquifer completions. The state of Wisconsin does not require a single aquifer completion. You can complete out of multi-aquifers within the state, but the recommendation to the city is that no mine be allowed to make a multi-aquifer completion, period. I mean, and it needs to be cased through the Eau Claire confining unit into the top of Mount Simon and properly grouted. The wells need to be monitored for specific geophysical logs useful in interpreting both the geology in the area as well as confirming casing depths, cement logs, that kind of thing, so that it's ensured that the mine's water production wells are completed only out of Mount Simon and properly done so. Those are my recommendations, basically those two things, based on groundwater quality and quantities.
If we could take 161 minutes of everything and compile it into a farewell 2 sentences as far as when this council debates the merits of moving forward or stopping or anywhere in between, how would you sum up what our duty needs to be and what we look at for data and recommendations? You know, because we want to make a decision based off of reality, not fantasy or theory.
Yeah, the 6 points that the county looked at were community, stable communities, surface and groundwater, light pollution, noise pollution, air quality, radon and radioactivity. Those are the points that the county took a look at for health effects. I think Larry addressed the air quality, and I've talked about groundwater and water. The rest of this, light pollution, noise pollution, quality of community, that's kind of the quality of community is kind of on a firm line. What do you hang your hat on? To assess that quality. Light pollution, noise pollution, I'm not an expert on it, and so in my review, I basically ignored these and basically told you that I did look at those things. But those are the things that need to be addressed in user permits, conditional use permits. And the rest of this basically can be protected in reclamation plans, ensuring that reclamation plans are properly written, which means that they need to be properly reviewed and stuff. So,
Well, you're going to help us administer those, so you're going to help us make sure it's properly written.
yeah.
I do have a comment in regards to your summary and analysis of the Trumbull County study. I noticed that there are 2 or 3 people here this evening that were on that committee. I'm wondering if you could have a comment from them if they so desire.
I'd absolutely encourage that and welcome that at our next meeting when we have a forum for public comment.
So if you're saying they can't speak tonight.
I'm saying that we started the meeting by saying that we're going to have a public forum and encouraging public participation at the next meeting. Absolutely. Last thing to cover by the city prior to moving on the agenda is the summary by the Wisconsin Department of Transportation, which I believe Councilwoman Colstead asked for an analysis on that at the intersection of J95. Or that was about a month and a half ago, you asked about that 2 months ago?
I asked you for some statistics there.
I'm waiting for the final report of the email summary that Rick sent me, and Rick's here, we're talking with Rick, what's his last name?
Toolman.
Okay. He said the intersection at J95 currently operates at a level of service C during the afternoon peak hour. We felt that analyzing the intersection during the highest peak time would give the worst case scenario in evaluation of the operation of the intersection. We added approximately 15 trucks in the peak hour for each mile that could potentially add traffic, assuming 150 loads per day. And we added 150 trucks for 10 miles, so that would be 150 vehicles per hour, and the level of service did not change from level of service C. It should be noted that the total volume is not the only factor that affects the level of service. It will also depend on the distribution of the traffic and the turning movements associated on each leg, which means if they're turning to go on County J, or if they're taking a left on Highway 95 or a right on Highway 95, or which lane they're in. So for all those different legs of the intersection, that level of C would not change for the 150 trucks per hour. It would also depend on the distribution of the traffic and turning movements associated on each leg. So that intersection, when we built it back in 2009, we did it right. We built it to be able to handle everything that it does, and at its peak absolute worst, could still handle 15 trucks per hour for 10 additional miles. And they just, I said, give me your worst case scenario, what would it?
So you're saying it can handle 150 more trucks per hour?
Yes. And I was thinking that.
Or vehicles, I should say.
Vehicles. Yeah. And their thought on that, and my understanding of their thought on that was that there's one vehicle occupying that space at any one given time. And the lights are designed that if there's somebody at the intersection, then it changes, and if it's not, then they go straight.
Is that the ruling that the state would give us?
Yes.
What you just told us?
Yes. I wanted to provide that tonight with the full council here as well. So. With that, future agenda items, Mr. Conner, if you asked that to be on the agenda.
Yeah, I don't have anything.
This is Mr. Elvis. Ms. Holstead.
Is this at the next meeting, public meeting, or our next council?
Which one would you like it to be?
Well, I'm asking you, I don't understand what you're asking.
For the next public information meeting.
Not at this time.
Okay, Mr. Fetch.
Not at this time, we're gonna have further public meetings after that.
Yes. And the idea is, and I again thank Riverland Energy for letting us use the facility here. Jerry, I don't know if you're still here, but our next one is going to be at the Arcadia High School in the auditorium, which would accommodate a much larger crowd. Again, it will be on the city website. That from the Trumbull County Times is going to help us get that information out there as far as the date and the time and the agenda. And we will also work with everybody that's got a billboard on 3 banks in town to make sure that is put up there as well.
Is it possible to make these into maybe 2 or 3 different public meetings? Have air one night, water the next night, cut it down, make the time, people sitting there for 2 or 3 hours.
Yeah, I guess we could do
I guess
that.
I'm not a chemist, I'm not a water expert, so to dissect all of it in one night.
Sure. And we're not either, nobody sitting here at the council table is, and that's why we brought in the guy with the degree.
You know,
Because
if you keep it under 2 hours.
we got
That's gonna,
Mr. Mayor?
Yes.
public comment is gonna get a lot.
Absolutely. That's a very good point, because that will extend that a couple of minutes.
I would like to see us notify, be able to notify our constituents, I'll use it, you know, the ones that are from the city, because either city people aren't concerned or they weren't notified, because how many are there here tonight, other than people over here?
I got covered by it.
It's Gary Bouch, one of them?
Yeah.
But he's on the planning commission, so you don't know.
You don't count.
We'll make sure that it gets posted, and I tell you what, as soon as that meeting date and time gets out there, by all means, let your neighbors and friends know. I encourage people to be there. And the other thing that we're going to do that night is to take a look at actual proposals, because a lot of this is, like I said, until you have an actual submission of a CUP application, it's theoretical, it's abstract, but we can actually look at a project then. So, Sal, did you have anything? And Mr. Wojni? All right, with that, the chair will entertain a motion to adjourn. Angela, motion by Councilman Zalpa, seconded by Conrad to adjourn, and a vote whenever you're ready.
Wojni.
Yes.
Gonzalez.
Yeah.
Batch.
Yes.
Olson. Conrad.
Yes.
Thank you, everybody, for coming. I appreciate your attendance.